Hello and welcome to Group 7's rocket design video. The objectives for this project are to design a water rocket that protects a payload of an egg and to maximize the duration of the rocket's flight. Unity and Microsoft Excel were used to figure out the optimal conditions for the rocket's flight. What is impulse? Impulse is the total change in a body's momentum and the product of the average force and the time over which the force acts. Therefore, you would be able to find an impulse over a given time by integrating a force-time graph. The force created is thrust, which is generated by pressurized water that comes through the nozzle of the bottle. Using Unity, we found that the optimum water fraction was around 30%, and this achieved the longest flight time. What is directional stability? Directional stability is the ability of a body to be able to return to its original direction after being disturbed. The addition of fins increases the stability of the rocket in this case and lessens the effect of wind. The optimal position of the fins was found to be near the bottom of the rocket, ensuring they are below the center of gravity of the rocket to increase the directional stability. It was also found that the optimal size for the fins was to have them reasonably small, as if they are too large, they may turn into the wind too much. How is terminal velocity reached? When the body is falling and the weight force equals the drag force, there is no resultant force and thus no acceleration. This means that the rocket is descending at a constant velocity, which is known as the terminal velocity. When using this idea with respect to the parachute system for the rocket, a larger parachute diameter means a lower terminal velocity. However, another factor to consider is that the larger the diameter, the longer it will take to open. One of the real-world considerations is that the weather may be windy or rainy, so the rocket must be built with a reasonably high build quality to withstand these conditions. It was found that at certain lower build qualities, the parachute did not open. The rocket is made with waterproof material to protect itself from the rain, and the pieces are firmly attached to ensure no wind can cause the pieces to come apart. It was found that the best and most realistic conditions were light wind, which simply meant that the rocket would tumble slightly as it reaches the ground. What are the conclusions and lessons we have learnt about rocket design from this exercise? Before the exercise, we were unaware of how important fins are in terms of stability of the rocket. We now know that it is imperative that the fins are below the center of gravity of the rocket and are of a small enough size so that they do not increase the drag of the rocket. Prior to this project, we weren't familiar with software, such as Unity and SolidWorks. But, having done this project, we have all understood how to use these applications much better. We didn't know how difficult it would be to remove the nose cone from the rocket during flight. And the solution to this issue is to try to ensure that the axial drag on the nose cone is less than that on the body.